Hello, there you go. Okay. I'll move this to the side. Alrighty. Welcome back, everyone. I'd like to thank you for coming here today, especially given that, it's cold and snowy and generally, and it's also right before Thanksgiving break. Um, we'll make this workshop, not, kind of quick today so that you can go on with your weekends and whatnot. But as always, we'll start with a little recap of like the news over the past few weeks in the XR space and whatnot, and we'll go right into our workshop where we're going to be covering some sort of more pro and maybe some like advanced CMD or C sharp techniques that maybe can help you level up your experience or maybe learn something new. And it'll be fun. So to start off, this is sort of, I guess, VR adjacent news, but Microsoft Flight Simulator uh, 2024 has just debuted, I think, a few days ago, or like in the process of debuting. And while not explicitly VR, they are flight simulators in general are often like a big target audience of VR. And I don't know, I just thought this was kind of cool. Like, here's a VR flight that Upload VR did going through Las Vegas, and I guess what really stung me as being particularly impressive is like, you got like the nice little sheen or like the glowing effects or the blooming of like the sphere or whatnot. And it's particularly makes me pretty glad that they're continuing to support VR because I think when the last version of Flight Simulator came out, I think FS 2020, they were kind of iffy about whether or not they'd keep it, but lo and behold, they are keeping it. So I'm pretty proud about that. Next up, we got some I'll pause this. We got more rumors about Valve's upcoming headsets. Um, as we all know, or if you don't know yet, Valve is rumored to be making a successor to their most popular VR headset, the Valve Index, codenamed Deckard. This is supposed to be a portable, standalone headset akin to the MetaQuest, but you'd basically instead be able to run any sort of Steam VR titles you want. And recently, Brad Lynch, the popular XR YouTuber, did some data mining into some updates of Steam VR, and they found a bunch of references to like controller layouts and whatnot, or like the code that would actually like map the buttons to actions in the game. And I believe it suggested that it would actually for one, I think it's not really pictured in this diagram, but I saw like there might even be a D-pad on like the VR controller, which is interesting because no no, as far as I'm aware, no VR controllers today feature a D-pad. It's all joysticks and whatnot. And this could be pretty interesting in the sense that like Valve may actually be more maybe using this as like a Steam Deck on your face or whatnot. Of course, it's Valve, so we'll see if they do anything the next ever. But at least that the good news is we're continuing to get stuff trickling in. And as like a little aside for all you, because I'm a Valve fan, they also did like this huge Half-Life anniversary thing for 20 years recently, which is, or sorry, 25 years. Um, or I don't know if this is it. Uh, oh yeah, 20th anniversary documentary. And if you love game design, I highly recommend you check this out. They talk about everything that led into Half-Life and eventually I think getting up to like Half-Life Alyx, the VR game. And it was really cool to watch. So, if we happen to have some time this weekend or over break, I highly recommend it. But I digress. The MetaQuest Link PC app now has casting remote desktop built in, which is very, very a welcome change. For one, it has always been a pain point when you want to be able to demo like a Quest experience or project it or whatnot to how exactly you go from like casting it from your phone or the Quest to like a TV or phone or whatever. Do you have the right phone? Is it logged in with the same account? Do you have a Chromecast ready? Like all these questions and having it being able to cast it directly to the PC also helps for all of you people who want to showcase your creations because you can actually screen record the output directly to your PC and do whatever you want from there with that. And they even have like the remote desktop client built in too, which is something that Meta has also been trying to really kind of push forward with Microsoft recently. I think even as far like a few days ago, Microsoft had their big sort of what should we call it? Like they had their big conference event where they invite everybody, and they were showcasing how soon enough or like you'll be able to like use a Meta Quest and like connect your Windows PC in the cloud or whatever, and like have all these different virtual desktops or whatnot. But uh, I guess to compete with like the Vision Pro's virtual display. But long story short, it's nice that we're getting most of these features built in as a convenience instead of all these different apps. It's become more streamlined. Also, recently, The Weeknd made a new Apple immersive music video. I heard it's really good. I haven't actually seen it yet myself. I'll probably see it this weekend. But it goes to show that Apple is continuing to invest in immersive media, uh, or like sort of the cinematography aspect of it. We saw a few months ago, if you remember, their Submerged film and whatnot as a short story. Now they got a music video, and it's really exciting to see that they're continuing to kind of invest in this medium and like get a lot more like artists on board because it'll be really cool to see how the next sort of 5 years play out or whatnot. Other than that, B Haptics has new vests and armbands that actually won't break your wallet as much. We of course at the XR Lab we have like their sort of, I guess, if these are cheaper ones, like their best or deluxe haptic vest that you can try on and whatnot. But traditionally it's been kind of, hard to justify like why would I buy a haptics vest if it's not universally supported on the games? Do people even actually know that they exist? Do people know how to actually connect them to their devices and et cetera, et cetera, et cetera? And certainly the price point of being at like $500 just for the vest, I think that's what it was previously, it's certainly not going to help you address any of those concerns. So them trying to make a maybe more streamlined, maybe less capable, but overall more affordable vest would actually do wonders for making sure that haptics technology not only gets into the hands of customers, but actually developers are more incentivized to build in haptics in people's games. I know a personal friend who works on Veil VR, and he did I think he did the haptics implementation for them, and he was like, he was blown away by how like good haptics can make a game feel. But then again, it's like that's really cool, but if nobody has it, how do you justify that developer effort, right? And so just efforts like that is going to help make things more affordable. um, Next up, Meta is continuing to try to bring VR to colleges and universities. I believe that they're trying to open up new programs to help like sort of incentivize universities to like adopt VR in their sort of educational curriculums and whatnot. I don't know if UMD is in that at all. Maybe, maybe not. But I what's I guess beneficial for me as a developer to see is that like building educational apps in like a VR MR space is going to have or be a more lucrative industry or like have more opportunities for you to really make a difference. And I'm particularly excited about this because at my team at like working at like at the Earth System Science Interdisciplinary Center at down the street. I can actually even I'll do a little self promotion. Yeah, here, this is exactly what we're doing. Like this is like building VR like educational apps to help increase awareness about different material or topics regarding like in this case geoscience. But all that needless to say is that like more headsets being equipped in universities can only be a good thing. And last but not least, before we start our workshop, this is the my personal favorite thing to come out over the past few weeks is the long-awaited ultra wide display for the Vision Pro. um, this is what I absolutely love about like I guess Vision Pro, or what like these sort of immersive technologies provide in general, is just the ability to get a nice continuous ultra wide monitor at a moment's notice from anywhere. One thing that kind of like struck me as odd when I first saw this, like the fact that they did one continuous ultra wide monitor, because at first I was like, why not make multiple separate monitors that you can kind of pivot around as like how you like? But I actually kind of agree that this is the better way because there's no need to have breaks in the monitors when you can have a continuous plane or curved surface of however grand dimension you want. I just wish personally after using this, because I love this, it makes my workflow more productive. But it's kind of hard to arrange windows because it's like the software for like snapping windows to corners is designed with the assumption that it's like a big I guess singular monitor, and it's hard to kind of like divide things in nice into columns. Whatever, that's a nitpick. It'll obviously get better in the future, but I'm very glad to see that this finally hit the light of day and it's now out in people's hands. But hopefully, this will help continue to make the next iteration of Vision Pro or the Vision series more affordable for consumers. All right, so that's basically a recap of the news. We can now get into the workshop. So I guess because this is more of a chill day, not many people here. This is not there's not so much slide material necessarily. This is more a choose your own adventure workshop. So I think one of the things I have a variety of topics, anything from coroutines, C# extensions, unit tests, a bunch of stuff. I'll kind of go forth and I'll kind of go for these in random order, but if anybody has any particular topics they want to cover first, I will definitely be willing to hear that out. But I guess the thing I'll start with first off is C# extensions. So let us jump right into Unity. So how many of you are here are like CS people? Oh, I guess that's yeah. Okay. Are you into you're CS, right? Okay, yes. But good. Because you'll particularly like this. So uh, you know, I guess to ask like oh yeah, sure. Thank you, Ian. Now, uh, so uh I guess to ask a trivia question that probably all of you are familiar with, but just to do it anyways, what programming language does Unity use primarily? Perfect. We all know that. And the comparison I usually make when pitching it to people, it's like, it's Microsoft Java. It's very similar to like the Java that you know and love in like 131, 132. Generally speaking, obviously, there's tons of simplification there. But what that leaves out in that simplification is not only is it similar, but it also is, in my opinion, much more advanced. It gives you much more functionality than what Java gives. It's a very much more of a daring language per se. Like you have tons of this additional functionality, which is really cool. So here we're going to demonstrate that today. I'll make a C# script called extensions. Let me fire my IDE of choice. I'll trust it and open it. Alrighty. So for this example, what I'm going to do is I'm going to also zoom it in so you guys don't have to strain your eyes. We're going to make a rect called rect. Very similar rectangle, right? Um, there you go. All right, good. So if I go into Unity, I attach the script to my game object, call it extension, so I can divide a rect, boom, we get a rectangle that we can define. We can define it, let's say, at the origin and give it a width of 5 and maybe a height of 2. Beautiful. Now, let's say we wanted to calculate the area of this rectangle, right? I try to look rect.area. Nope, it doesn't exist. There's no area method. Hmm, that's it's really unfortunate. So I guess somebody tell me how we go about calculating the area the straightforward way. Advice. Yep, we could do this where you go rect.length or rect.width equals rect.height, right? Gives you the area. That works. But imagine if I gave you like 500 rectangles or like not necessarily 500 rectangles, but you had to like calculating area was very important to your game or something or your application or whatnot. Wouldn't it be tremendously annoying to do this every single time? I mean, obviously, this is not so bad. This is just area. But imagine if this was a more sophisticated computation that, like, you don't want to, um, you don't want to like, redo that every single time inline, per se. Inline being that like you're literally spelling it every time. So, as computer scientists, what is the first order of business we do when we see that we're doing an operation over and over and over? I'm gonna call you, huh? We could do a loop, yes, but like generally speaking, if we're doing like an operation multiple times throughout a code base, what should we do instead of repeating the operation over and over and over? Yeah, or not necessarily like a class or like yep, precisely. We would make a method. Um, so in that case, I would make maybe I think what would be smart is I do like I have a get area method, or I guess it's not really getting. We're going to calculate area, and we take in this a rect. And then we can return. Oh well, look, Ryder's smart enough to autocomplete it for me. Thanks, AI. We can even go ahead and be, resort like good programmers, mark it static because we don't actually depend on any instant variables of the class. And now, when we want to calculate the area of this, we can just call our calculate area function and pass in our rect. Does this work? It works. I'm happy. But let's consider the case where we have another script, other extensions. And let's say this too has a, rect, has I'll also increase the font size. This also has a rect, maybe two. And I also need to calculate the area here. Let's say debug.log. The area is now call my calculate area or, uh, but then I want to call my calculate area, but then I can't just call it like that. I need to actually refer to the class it was created in. So it'd be extensions.calculate area rect or rect one. Does this work? It works, right? What about you? I think this is ugly. Wouldn't it be so nice instead of like defining this, you know, having like this ugly sort of like, base class dot my method type thing that it didn't need to be there at all? Wouldn't that be nice? Be very clean. So that, theoretically, instead of doing that, I could just do rect one dot calculate area. That would be quite nice. Now, typically, the way you go about doing this, if you had complete control of the whole code base, is that you go directly to the rect class and then you add that method yourself. But then for one, the first problem with that is surprise. This is basically good luck modifying this because this is all. I think this is decompiled anyways from the source. Yeah, this is all. So when you see this IO code here, basically, you know, you're not doing that. Second off, that's not only necessarily difficult from a technical standpoint, but it's also bad from a programmatic or like a design perspective too. I think there's a principle called an object oriented is basically uh, closed for modification, open for extension. I think something like that. Basically, a principle that like instead of every single time you need to modify behavior, you don't necessarily jump right to the source and like add your specific use case. You extend it um, to like sort of add on what you want instead of like modifying the server every time because that leads to cleaner design patterns, not bloating any particular class with a gazillion methods. And yeah, but unfortunately, like we can't do this really clean thing, or can we? Well, C Sharp, one of its best, most popular features, in my opinion, is the ability to do just this. And the way you do these, or this sort of technique is called extension methods. And that basically allows you to like sort of it's basically what's called syntactic sugar. It's not really doing a whole lot of crazy things behind the scene, but what it is doing is that it'll let you do the shorthand of like, when I have some new functionality you want to add to some existing class they may or may not have the direct ability to control, I can actually do so myself. And it's super, super simple to get going with it. So when you want to make sort of extension methods like this, what you first need is something called a static class. So we're going to go over to our scripts. We're going to make a new thing and call it like my extension methods, whatever. I can take out this namespace because it doesn't really matter. So yeah, we have a new class. We will call it my extension methods. Now, remember I said we need to make a static class. So basically, right now, this is a sort of a regular class that can be instantiated. You can make instances of it. But in order for these extension methods to work, you can have that. You need to actually make the class static, where it's basically just a glorified namespace in the sense where it's like just basically providing a way to define a bunch of methods, but it's not actually going to be, you can't create instances of the class. That's just a requirement C# gives. And so to do that, it's really simple. All I have to do is type static. Yay, not so hard. But now we can start defining our extension methods. So I can come right here. I can even like go here. I can copy the exact same implementation, import the rectangle, and there you go. So let's try to go back and go do this. So I'll do rect dot calculate. It doesn't show up. That's unusual. And I mean, I can still like call it. So I can do my extension methods like calculator. Like it exists, but what gives? So when you make these static classes, you have to explicitly opt in to making it like shorthandable. So right now, this is basically just a plain old static function or method. You can just you can call it as per usual, but right now there's nothing really fancy about it. To unlock that true power, that nice syntactic sugar that I love so much, it's really simple. All you have to do is add this. And what this means, or tell C sharp that you're saying, okay, I want you to basically kind of latch on to like this class, or with this keyword, and this makes it so that every time that you want to use any sort of instance method off of like that class, you have the ability to use this as well. And so basically apply everywhere in your project where you have access to like these extension methods. So now when I come back to Unity, look at that. Writer's already like keen to this. So you can see here, this is a green line. And the reason why it's showing that green line is because it's saying, oh, by the way, you can actually make this extension method invocation. And if I just enter, look at that. This, you don't even know how good this is. Like, particularly for libraries, actually, we will look into how this is utilized later on when I talk about Unitask, which I love a lot. But you can imagine the tremendous applications of this, right? So, like, especially maybe you won't have like too many instances of this, like maybe a quick hackathon project you're doing. But let's say you're trying to build tools for other Unity developers to help, do the thing or whatnot. Being able to latch extension methods like this is like a really nice way to like make it look very clean and whatnot. And it's I can't rave about it enough. But yeah, there's a lot of power here. And you could do anything a regular extension does. So maybe I want to, let's say, maybe you want a a function that like does double rect. So basically it'll like double the size of it or whatever. So rect, and we can say we can return new rect. Is it already, did it know what to do? Oh, it kind of did for a second. So I can say x dot, whoopsies, y, x with y width times 2, rect dot height times 2. Also expand this. And once I define this extension method with this, once again, we can come back here and can say a double is my rect, or rather double rect is rect a double size. And boom, just like that. And the last thing I'll say about this is that like regular extension methods, or regular methods, you can also provide multiple parameters. So if I just said like, I'm just gonna make it foo, I won't have it do anything particular. But I can go ahead, I'll say public void foo, and I can do float x, float y, or something like that. This has to be a static method. There you go. So you can see here that you can also pass in parameters kind of as you would expect, and this will be really useful for sort of further customization. Now, the only limitation of this is that for these extension methods to work, they have to be instance methods. Like you have to have an instance of the thing. That's the only thing you can add them onto. You cannot add them to other static classes. And generally that's fine, but I particularly kind of, in making kind of toying around with Unity myself, I found this to be the most problematic when I want to maybe sort of lob things onto like core Unity libraries like or static functions like GUI. So you might have like GUI.button, GUI. Let's say for those unaware, we can actually talk about this later. You can make like a button or using the immediate GUI by doing this kind of call, where you can say like my button, and then like the result of this is like whether or not you press it. Maybe let's say you found like a use case in your application where you want to add like a different style type of button, and you would like to add an extension to GUI, which is I believe to be a static class, uh, or not necessarily a static class, but a class that has static methods. But unfortunately, you can't do that. You like there's just as far as I'm aware, there's no way to add like you can't make your own like GUI out my custom button or anything like that through an extension method. It has to be an instance of it. That's kind of unfortunate. Um, Maybe a future C sharp version will add that functionality. Even if it does, it doesn't really matter because Unity will take another 5 years to upgrade to that C sharp version anyways. So I don't see it happening anytime soon. But oh well. Needless to say, in most cases, this can be very helpful for you, like I said, especially when you're concerning like, you know, extending functionality of stuff that you don't have access to. So pro tip number one. What else do we have? Um, we can also go through maybe a more in-depth look at coroutines too, because that would be a really natural lead into unitask, which is, I think, the better way to do coroutines. Oh, sure. Yes. Yeah. Yeah. That is the, or you want to, yeah. 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 Both very good points. And I guess on that note, something to mention too is like it's also good. I would say it's good design to also probably like kind of like what you're saying to separate your extension methods like maybe just have a static class just for like the methods you're adding onto vectors, for example. Like when I started learning about this functionality, I just started like, oh my gosh, extension methods everywhere. Like I ended up amassing this huge static class of just like methods that are modifying a bunch of different classes, which is not going to help developers, your team per se, because now you got to dig through this huge file, like where it might not be organized in any same manner. So it's helpful from a design perspective. Instead of saying my extension methods, you might be able to say like my rect extension methods. And that helps too because if you ever, I guess maybe for the sake of clarity or whatever, you want to be absolutely explicit that like I'm using this method from this static class. You can still call it as per usual, and no, it will still work. But yeah. The other thing too, actually, that I remembered before I switched on to coroutines is that in C sharp, you can declare variable, like you notice here I'm using var. You can declare variables of an explicit type by mentioning their type specifically. So I could say like float new width equals 5. But a lot of the time, especially in local variables, maybe it's not necessarily important to like get the nail down the exact type. I mean, you could have a debate here whether or not that's good design or not, but needless to say, Unity or not Unity, C Sharp has this nice little var shorthand, which is basically going to infer the type of whatever you assign to it. So if I assign 5.0 f, and by the way, this f also means to specify a float, it's going to infer this to be a float, and so it's going to basically store this will be a float, and by the way, you cannot change the type of this, so you can't come around and say, actually, just kidding, I want a string. No, you can't do that. I'll be mad at you. But this is particularly useful, I guess, when you're more, I guess, uh, you know, you want to focus more on like actually implementing a particular algorithm or functionality rather than like nailing down the exact type. Because you can imagine, if you have like some crazy class or generic that you're getting from a return value, it might look kind of ugly to have like this really, really long class name or generic, and having var will help you mask that. That being said, of course, this is up to debate, obviously, because while it does add the shorthand, it makes it nice. You do kind of lose some of that clarity, like what exactly is the type. You can't really tell from first, like at least just purely from the text. You need your like IDE to tell you, or kind of run through it yourself, because there's also issues where it can kind of come to bite you. So let's say I was like, okay, I want, I have a new width of 5 and I have a new height of 2.0f and or let's say 2.5f, 2.5, whatever, and I want to calculate my new area. Can anybody kind of see what issue I might run into here? Oh, yeah. No? Well, we'll see what's happened. Actually this will be fine if I calculate it like this. But let's say I wanted to uh let's say I wanted to add like Yeah. So yeah, precisely. That's like issue I'm trying to highlight. So let's say instead of doing this example, let's say I instead of wanted to extend my width by another 2.5 centimeters. So I'm going to plus equals 2.5, and then it's mad at me. And that's because when I specified that 5 here, this is actually being interpreted as an integer. So this gets saved as an integer, right? So when I go, even though I like maybe in my head I meant like, oh, I mean 5 is like a floating point, right? But if you forget to specify, like, I mean, this is an example just with floats, but in general, you could probably come up with, uh, yeah. But I don't know. Everything has trade-offs. I tend to like this. I mean, Ryder screams at me if I don't like. I think it like the way I learned about it is like I had all my types explicitly defined or whatever, and then Ryder will kind of just ever so like gently remind you, hey, you can make this var and whatnot. Of course, you can tune those suggestions so that if your team doesn't like that as a design practice, you can ignore it. But yeah, all right. So that's basically what I have to say about that. We can move on to coroutines really quickly. So let's say I want a script to go move up and down, sort of like this. I'll make this a mono behavior. And basically, I want to have some sort of method on here that, not the best like in terms of names in the world, but basically it will cause the thing to go up and then it comes back down, right? Uh, I, if you don't have coroutines, maybe your thought process is to do this like, okay, well, I need to have something in the update method that will basically like continuously move its position up and then down. But then the problem becomes like, well, if I have an update, it's going to always move up and down. I don't have any control about like when I actually do want to do like move up and down. Um, and then maybe you can get around it by like, okay, I can maybe store like the time that like I was requested to move up and down and store that. But as you can kind of see, it's becoming a very difficult problem to manage for something that should be pretty simple. Like all we're really doing is basically move up, move down, you're done. And especially any sort of operation you want to involve some sort of like calculation or sequence of events over time, you want a different sort of workflow. And that's where coroutines come into play. So coroutines are basically a way of sort of, like I said, staging operations to happen over time, over frames, rather than using like some sort of convoluted update logic or whatever. And the way you define them is very, very, very simple. All you have to do is say public IEnumerator, because IEnumerator is basically the type of a coroutine, and we can kind of go into why that's the case later on. But you can say move up and down coroutine, and then you can actually right is kind of spoiling it, but like we've defined a coroutine, yay! But actually, how do we like? What does this mean? Like, how is this different from anything? Well, in contrast to a regular function or regular method, instead of returning something like a value or whatever, we can actually return different sort of, I guess, signals to Unity that inform it, like how long to wait or like whether it should like do something else in the meantime. So let's say, like in terms of pseudocode, we basically want to move up for like 1 second, maybe wait 1 second, and then move back down for 1 second. Like if we wanted to program this update, it's like how do you actually tell it to wait for a second? Well, maybe you have to measure the time, and yet like that's really annoying. But with coroutines, you can actually like really easily sort of just to kind of sequence this logic. And the first way you can do that is like you can basically do what's called a yield, like wait for seconds. So if I want, anytime I want to like basically perform some sort of action or code, wait, and then continue on, I can do something like this: yield return new wait for seconds 1f. And basically, anytime you have yield return here in this way, because this is what like I guess distinguishes a coroutine. Under the hood, this is really like enumerator syntax, but for our purposes, like this is how we're designing this coroutine. This is basically, as the name implies, it's yielding to Unity to go do something else and come back to me when this condition is met, right? So we can say, run this code, then go off, do your thing, whatever, and come back to me after 1 second. And so already, that's a pretty cool, like nifty way to just really succinctly specify that logic. Furthermore, we have different like sort of like conditions we can go on. So in this case, we're waiting for a second. We can also like do what's called a yield return null. This seems, it's basically like a shorthand syntax kind of way. It does seem a little bit confusing, but what this actually basically means under the hood is wait 1 frame. So anytime you basically want to do like a frame by frame operation, every time you yield return null, you're basically telling Unity, okay, go to the next frame, please. And this is particularly useful when you're doing any sort of operation involving time, as I'll show in a bit, where basically you might like say, okay, go to the next frame, figure out how much time has elapsed, move this position by that much, next frame, next frame, next frame. And basically you like, let's see, you have tons of these. You can do like wait until, which is basically, you can provide what's called a lambda, or we can go into that. That basically like a condition you check every sort of frame to see whether or not you can proceed. So maybe I have some sort of like, uh, let's say I have some sort of API that tells me whether or not I can proceed or something like that. I'm definitely making up like a pseudo example here, but we could do something like this, or we can even say can proceed like this. We can directly specify the name. That's kind of a nice feature of C Sharp, where you basically, Unity will wait until this function or this method to return true, and then it will proceed. There's a whole list of these. I won't go into like all the nitty gritty builds right now, but you can find them online. If you just search up, I think you probably can just search up, I don't know, Unity list of coroutine functions or something like that. Uh, Probably here somewhere. We can track these down later on. Like, oh yeah, here. So like here you can see like wait for end of frame, wait for fixed update, wait for seconds real time, yada yada yada. So tons of these operations. But enough of that. Let's actually see a practical example. So when we want to move a cube, let's say, or like move something, I guess, up and down, what we really want to do is basically be able to like somehow take a starting position and an ending position and sort of go from start to finish and like animate over that. And I don't know if you know, but like the way that you do sort of any like sort of a go from here to there operation, especially in game programming / linear algebra, is a lerp. So you're basically you specify some value between 0 and 1, where 0 is your start. So you can imagine like if it, like in the one-dimensional case, like this is the start. You have some space in between, you have an end, and maybe your cube is here. Like right here is basically would be a t value of 0. And then you basically interpolate all the way through until you get to the end of 1. And what we can do is that we can utilize a coroutine to basically calculate these in between values over time and sort of like animate it for us. So a common pattern, like the simplest pattern you can do to do this is, let's say we'll take in 2 parameters as input, so a start and an end, because by the way, coroutines are just also, there are functions, you can just specify this regularly. And what we'll do is we'll first keep a elapsed variable, elapsed time. I won't make my own mistake. I'll remember set that to float. And what I'll basically do is I'll basically say while elapsed is less than some duration. So I'll also add like a duration parameter that allows me to specify how long the animation took place. We're going to calculate the t value, or basically calculate this in between value by taking sort of the elapsed divided by the duration. Basically, you can imagine if like this whole, like, let's say, above this sort of graph is the time. Let's say, this up here, we want this to occur over like, I don't know, like 1 second. right? If we know, if we were basically keeping like a little stopwatch, and we know that we've like maybe proceeded like maybe halfway through, so let's just say that we know we proceeded 0.5 seconds, right? Then we can calculate basically our normalized t-value here by taking the duration of elapsed time over like the total duration we want. So elapsed over duration, because 0.5 divided by 1 is just 0.5. So that's a t-value of zero point 0.5 or 50% of the way through. And this would work with any sort of time values, right? Because if I made this like maybe 8 seconds and like 2 seconds, this would be maybe like about a quarter of the way through, because 2 divided by 8 is 0.25, and that's a t-value of 0.25. Does that make sense? And so we're basically just going to be calculating like t-values in this way using this coroutine to sort of like animate over. So basically, I'll calculate the t. I'll calculate the new position by lerping between the start and the end for the duration, or rather, given this t value. And then I will basically add to my elapsed time by taking, right, so that's me basically delta time. And here's another, I guess, pro tip. Time to delta time basically represents the time that has elapsed between like the current frame and the last frame. So each one of these, like, you can imagine that each one of these little like horizontal bars here is like a delta time amount of time. So like this is delta time, this is delta time, this is delta time, et cetera, et cetera. And you can see basically like you can even see this kind of visually. The way that we're building up the total elapsed time is like adding each of one of these like deltas up, and that will give us how much time has elapsed. We'll see these come all into play, I promise, because I know this is just a bunch of ASCII and coding right now. But there is one part here I'm missing. Like the algorithm is almost complete. It's we have the elapse. We basically keep looping until we've reached our duration. We calculate the t-value. We calculate a new position, and I'll also say that we can set the new position. But there's something that we should do in between this new position and then like adding the elapsed time. Can anybody guess what it is? It is one of these. I'll give you a hint. No, it's fine. But basically, we're trying to do this logic per every frame. We want, like, as like a reminder, we are trying to make a script or a coroutine that moves a cube, like, or whatever object, like, smoothly from point A to point B. And so, you know, in between, like, calculating while we're animating this thing, right? We don't want to wait for some lengthy amount of time to like step it up, because then it's going to like move once every, like, this would move once every second. That's like literally a 1 frame per second animation. Maybe you do want that in some cases, in which case you can continue, you can use that by all means, but we want something smooth. We don't want to use like, I mean, this is like an example, but we wouldn't want to wait until like some other condition, generally speaking, was ready, because we want something to be, appear like a continuous animation that's not like lagging or whatnot. So we don't want this. So instead, what we're going to use is yield return null. And then this will basically wait 1 frame and then like repeat our loop again. Because we need this for 2 reasons. One, like I said, we need this to help, like, basically each yield return null is going to take us to the next little like tick here. So you can imagine like this would be, we do our work, this work here, we yield return null, that brings us to the next one. We add the time, we do the work again, we yield return null, which will take us to the next one. And each yield return null takes us to the next one, et cetera, et cetera, et cetera. The other death spiral you can run into is if you forget to yield return null and you execute this, then your while loop will never finish, because, well, okay, I guess in this example it will finish, because delta time will, well, delta time will always have like a, I guess, non-zero value, so it's going to eventually add up. So this is, I guess, a way of like having the loop complete instantly. But let's say maybe for some reason, you depend on waiting to the next frame to get your like, to update maybe this like case where you stop or whatever. You can end up accidentally creating an infinite loop that goes on forever. And in Unity, if you create it instantly, because like basically the whole player loop in Unity is just like one giant loop that like sort of executes everything in like your game, generally speaking, one by one by one, you will never leave this loop. And if you never leave this loop, your whole game freezes, period. including the editor, by the way. Been some nasty cases I've done when doing these where like I forget to set like properly set up this exit condition, and you have to basically kill your editor because your editor is stuck in this loop, and because everything you need goes on one thread, no bueno. So once again, yeah, remember to include this. But or yeah, oh yeah, that too. C sharp will also force you to like have at least one yield return statement here because otherwise it's the true reason for this is like for I guess the very technical reason why that you wouldn't need to know when just using Unity, but this is basically what's called like I think a generator syntax or numerable syntax or whatever, where basically you're basically trying to give back items in some sequence one at a time to some calling function. So basically, let's say I had I don't know something. I think the type is slightly different, but let's say I had something to give me numbers or something like that. And let's say I want n numbers. I could be like for var I equals 0, I blah, 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 I yield return I. Um, Basically, this is a way of like, let's see, what is it? Oh, yeah, int, and then report methods. This is basically a way of setting up a kind of like a for each loop, if you will. So I can say for each number, give me 100, like 10 numbers, whatever. Or like basically you can imagine like if you have some sort of really expensive operation or like a huge list of numbers, it may not be worth it to like construct like a list of like a billion numbers when you really want to do like one at a time operations. So let's say like we just wanted to like, you know, add each number to some total. Like we don't want to necessarily generate all these numbers, make like a gigabyte huge array when we're really just trying to do a one at a time operation that doesn't need all that. This sort of yielding syntax allows you to like basically make this number and you yield to the person that's calling you, they finish up their thing, and then they come back to you. So it's a very efficient syntax. But to get like this is a long-winded way of explaining that the reason why it yells at you if you don't have yield return is because you're supposed to be yielding something, right? Like that's the whole point of like enumerating over something. You're giving something back. And if you don't give anything back, it's going to not know what to do. And that's why you have to include something here. The other thing you could do is like in addition to yield return null, let's say maybe you found some condition under which you want to exit early out of a loop. You can also do yield return. I think you do yield break, and that basically says I'm done. So like like much like a return statement in like your like uh, regular functions, this will just stop it right then and there. So pretty convenient. Okay, but last but not least, I have this. Now I have this like we built this little animation loop to like move it from some from point A to point B, but this whole loop, the whole thing. The point of this is to move up and down, and so we're gonna have this code to move up, and then we're gonna have the code to wait, and then the code move back down. But we're computer scientists. We're good programmers. We want to be good, like make clean code. So I don't want to duplicate this twice. But the cool thing is you can actually like yield other coroutines to run in a coroutine. What that is to say in English is that basically we can move this to another function and like yield this operation, wait for this to complete, and then we can continue doing our thing. And I will just demonstrate that. So let's say I have like public IEnumerator move from start to end, whatever. I can kind of make the same sort of parameters, vector3, like a start, end, and then a duration. And I can just sort of give this operation like this, yield return null here. Oh, and another thing I like to do in these loops is that at the very end of it, I like to say transfer that local position equals to end, because sometimes when like you go through all these loops, you might not perfectly be at one per se. Like you might have like gotten very close to the end, but not quite, because like the math doesn't add up 100% per se. So I just like to set it like directly to like once you do this whole loop, once you animate it, definitively go to the end. That's just a little minor thing. Anyways, that is to say that now once we move this code, like we move this logic into its own sort of coroutine per se, we can just call yield return, move from start end duration, and we can just have this nice little clean thing by itself. So we can do this. Uh, Move from start to end. We can basically do like in reverse and from end to start. And oh yeah, and then like add the delay in between, and voila. This should work. So we can let's say let's provide some vector variables to define the start, this end, and like a duration. Um, it's going to be mad that we're overriding it. So I'll just say S and start position, end position, coroutine duration, just so that it like stops yelling at me. Then we can finally make our like move up and down function or method. And uh, now we actually need to run our coroutine. So we've defined it, but we haven't actually talked about how to actually run it. And in Unity, to do so, we call we call the function start coroutine. And so this basically will tell Unity to basically, given our coroutine code, just start executing it. And all we have to specify is the coroutine we want to execute. So we'll say move from start to end, or rather, we had it as move up and down coroutine. We provide the start position, end position, and the coroutine duration. And this is a fully working piece of code. In theory, we'll test that. But here, so we will now instead let's make our cube. We will have the move up and down thing. Or is this script? Did I forget a semicolon? Oh, let's get rid of this. We'll go back here, wait for it to recompile. Cube, move up and down. We'll just have it move from 0 to 0, the origin, over the course of a second, and we'll run. But you'll notice it won't do anything yet. And that's not necessarily any fault of our coroutine code. That's because I just haven't actually called this, move. I haven't called this like method here called start move up and down. Now, I can just simply, I can simply put this in like a start call, right? Or I can just do this. When we get our start event, we call it, and this would work. But this is a Unity pro tips workshop. So what if there's a cooler way to do this? Well, it turns out there is. Um, wouldn't it be nice if if we put it in start, it'll happen once and that'll be it. But what if I want to test it again and again and again with different parameters? But I don't necessarily want to make a whole new script to call it every single time with these new parameters. I just want an easy way to just trigger this from the editor. Well, my friends, we have what is called a context menu. This is what it's called, a C# attribute. This is a way of basically labeling our C# code and telling Unity, hey, this method right here, I want you to take notice of it. And so what we can basically do is we can basically give a name to this. We can say like start move operation or whatever. And this basically tells Unity, hey, this is something important that we might want to do. And it will point it to basically where it wants to be done. And so if we go back to Unity, what changed? Well, on the surface, it doesn't look like anything changed. But if you notice, I might have to, I apologize for the scale because I haven't cracked that down. But if I go to my component here and I hit these three dots, look at that. The very bottom is our start move operation. And I find this particularly useful if you're like trying to debug some like common piece of code or whatever, and like you just want to trigger some action to happen. You can add that context menu thing, and then you can trigger from the editor. Very, very useful. Now, the only caveat about this is that you cannot have any like parameters here. So if I just try to add like an X or whatever, you'll notice that if I go back into Unity, Unity's like, I don't know what to do with it anymore, and it disappears. Because I mean, because there's no like, I guess, I don't know. It's like it would be complicated. It's a complicated question of itself how you specify those parameters and serialize them properly. That's beside the point. Just know that like basically in order for it to show up there, it has to have no parameters, voidless or void parameters, whatever you want to call it. Very, very useful. And well, actually, enough blabbering. Let's actually, well, I hope it works, but we'll see if it works. Uh, and this is also this technique here is just useful too because like if you have it happen on start and then like maybe you're not in position to view whether or not it works. This way you can kind of explicitly trigger it. So I can go to the start, I come down here, I hit start move direction. Yay, it goes up and goes down. Wow, look at that. Beautiful. Yay. Now, that basically is coroutines. We can talk about like one additional tip is that you can also anytime you start a coroutine, you can actually get like a handle to it or basically a way to keep track of its progress. So I can say like running coroutine is equal to the output of start coroutine. And you can keep a reference to this. And let's say later on you're like, actually, never mind. I don't want to run you anymore. Cute like the Toy Story Woody dropping, whatever. You can call stop coroutine and you can pass it in this sort of handle. And this will like stop it right dead in its track. Furthermore, if given like some sort of mono behavior or like component, you want to stop everything on it, like all coroutines are running on it. There's also stop all coroutines, and that will basically kill all running coroutines on your mono behavior and stop them dead in their tracks. And basically, they will basically. I think what happens under the hood is that when like anytime you have yield return null, like you just won't come back. That sounds a bit morbid to grave, but like you'd imagine that like you run your code, you reach this yield return null, which is basically informing it's yielding back to Unity saying, okay, do whatever. But once you call stop all coroutines, Unity's like, I fam, I'm not gonna come back to you, and it just stops right then. And that's important to distinguish because basically one any code in between your yields is going to run to completion. Like this is basically maybe atomic is not the right word or term to use, but basically it's not like this, like in between here is not going to be interrupted, which is also why you run into those infinite loops because if you have nothing that's going to yield back, it's going to, well, go on and on and on. And on. But yeah, that is like a quick rundown on coroutines. Now, what if I told you we could do coroutines, but in a cooler way? Well, maybe cooler is up for debate, but I certainly very respectfully, subjectively cooler. And there are some additional benefits to this, which I'll show you. Um, uh, but it's, oh yeah, sure. That's a good point. So you can have multiple instances of coroutines running at the same time, but we didn't necessarily explicitly account for that in our code. So what actually I think that end up happening is like if we run this twice, we can just see what happens. They kind of might start fighting each other in a sense. You can kind of see. I guess it won't be so bad. But what is actually happening is that like yes, there are multiple of these instances happening at the same time, and it might start kind of jumping around because you can imagine that like Unity when it's like running this code, uh, let's just kind of represent it like this. I don't know the order in which it executes it in. I assume it's like maybe it's like the last one gets the most priority, but basically it's each one of these are going to try to set all the positions at the same time within the course of like a frame, but ultimately whichever one executes last and sets the final position is what's going to be the one you see visually. So that's something to keep in mind for when you are making coroutines is do you actually want the multiple instances of your coroutine to be executed at once? In which case, if you don't want that to happen, maybe what you could do is like you could do kind of this method where you kind of keep track of your running coroutines and if you want to start a new one, you stop them, you clean up after yourself, maybe reset it and launch another one. You could even maybe do that in like the logic of the coroutine itself, like the coroutine is able to check. I think in past, what I've done is like I basically set like I've given it like a coroutine ID, and then like while it iterates, it like checks if like the current ID is still its own. Or like there's many different techniques you can go to do about this, but it's basically that's different. Like that's how you can control multiple instances of coroutines running simultaneously. Right. Yeah. Yeah, yeah, that is true. So yeah, things to keep in mind. Which will become really interesting, like in our next topic, which is going to be called Unitask. This is I'll actually pull it up here. So Unitask is basically, we'll say coroutines on steroids. They basically, I'll show you why that you might want to use them in a second, but they provide numerous benefits, or maybe not benefits, but like perhaps maybe benefits to your team. And they allow you to mix asynchronous, traditional C sharp asynchronous code with like Unity and stuff like that. And they also achieve something called zero allocation, which I'll explain why that might be helpful in a bit. So, are any of you web developers in this room? Kind of? Okay. Can you think of an analogous thing that we're doing here in terms of in the world of like JavaScript or whatever, when we're basically doing yield return null? Yes, correct. This is basically us saying, can I kind of await maybe like next frame or something like that, right? Which is basically, you know, we do something, we wait for the next frame and we continue. And that's what we're doing. Um, but the kind of funny thing is that C sharp also has async await syntax. Like you can also basically, do the same thing, do some operation. Maybe you want to like read a file or something. Let's see if yeah, there should be async operation. Um, Maybe if I say file reader is a new file stream. I don't know. There do exist async operations in C sharp. Let's see if I can find one. C sharp read file async. Uh, yeah, so we'll just sort of copy this over. Okay, cool. This works. But yeah, much like JavaScript or whatever, we also have the notion of like I said, we're doing some operation, we await, so we're basically yielding back to our caller to say, okay, wait until like this finishes, do something else, and then we continue on with our merry way. But you can imagine that like it might be helpful, especially if you do have like a game that maybe is online or calls some external APIs to kind of blend these codes together. Like, wouldn't it be nice if you could just await this coroutine? Well, you can try, but it's like end position duration. But Unity's gonna be like, I don't know what you want me to do with this. You're getting an error that doesn't work. Nor can you try to get tricky, and you can't even do this because remember previously we were able to get a handle to this. Um, and like be able to like get the status of that or like stop it or whatever. C sharp has no idea what you want to do with this either. So that's a bummer. It is a bummer. Unless unless there's a way to get around that. So this is I don't know, it's kind of an extra. It is definitely uh, I don't know. I find it pretty cool. Especially because at least in my line of work, I do a lot of sort of data-driven applications where we are calling APIs, doing web requests, whatever. And I also find this, even when I wasn't doing that, in my previous game, in like a previous game I was working on in high school, I was trying to use async. I was basically trying to shoehorn coroutines to fit async await syntax in like a way that probably wasn't efficient. But this is the way to do it efficiently. So how do you install it? How do you actually end up working it? So first off, you're gonna want to actually not here. You'll come down to here, and then you can say install via UPM package. So we're gonna click that, and you basically copy this link here. You come into Unity and you go to window. Actually, well, I guess I made some changes, so it's going to reload. So stop it. We'll do window package manager, and we'll say um, add package by, actually, just kidding, from get URL. And we're just going to add it. And why is it mad? I did, didn't I? Thank you. I'm so sorry, H. All right, let's try that again. Okay, yeah, the H. Please work. And blah, 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 blah. Voila, it's installed. But what actually changed? Well, notice that somehow magically, if I come back to C sharp, and I try to do await move to end, start to end again, and I do the same thing, like duration. Now, oh wait, duration, or like this. Now when I go here, instead of being a straight up compiler error, it's actually suggesting like, oh, actually, do you want to use this? Do you want to import your missing references? I do that, and boom, magically, I'm somehow able to await this. Uh, so what gives? Well, unitask actually, like given the first topic of today's workshop, the extension method, makes heavy usage of them to actually provide you the functionality to straight up await coroutines in traditional async code. So this is particularly helpful when you sort of want to uh, mix traditional like sort of like file operations or API operation, whatever, with your Unity code. And it even provides a ton of helper methods to help you do so. So to sort of really illustrate the power of this, or maybe why or why not you might want to use it, we're going to remake these, but just purely with Unitask. In fact, believe it or not, we need not even use a coroutine at all. That is actually pretty wild. So instead, we are going to first, we have this helper method here, move from start to end. We're just going to copy it over. And instead, we're going to call it move from start to end async. And we are also going to change this for enumerator. We're going to change it now to void because this is no longer going to be an enumerable thing. And we're just going to add async. Now, first and foremost, C# is going to be like, hey, you can't, not only you're not enumerable anymore, but like now you're void. You can't do this. So what do we do instead? Now we do await unit task that next frame. And that's it. That is actually literally the only change we have to make. And this will work. And this is actually, not only this, I find this helpful from like a readability standpoint, right? Instead of this, sort of shorthand yield return null, like what does that mean? Now you can literally, unit task will tell you what that means. That means that we're going to wait for the next frame. All right. And now this is an async function. We can just actually call this where it doesn't matter necessarily where we call this. We don't even have to explicitly like we don't even need this anymore. We just literally call this and it'll like actually start animating. But to see that in full, we're going to continue swapping through. So now we have our moving up and down coroutine. We're going to copy it. We're going to change it, move up and down coroutine to move up and down async. And once again, we're going to async void. But once again, now this is mad. It's like, hey, you can't use you to return. Don't worry, bud. We're going to await you. Await. Just like that. So like right now, what you're seeing is the power of like how now we can just await these asynchronous operations. And this is, I think this is, oh, you are right, I think. I think I have to might do this. We'll see. Oh yeah. Oh, I see. You're right. Okay. My bad. So actually, in this case, I do have to say, I forgot. So we can't have it be void. We actually do need it to be unitask. And we're going to move start to end async. But actually, that shows another power of this. So not only can you like explicitly, uh, so you can explicitly make asynchronous methods in this way using just purely async await syntax. So this works. You do have to, I did make a little mistake there. You do have to set the return type to unitask. We can explore why that is later. But you can also, the reason why I didn't notice my mistake is that you can also just literally await. See, I can't pick like you can also like take any traditional coroutine that you've already written and call it just the same. It will basically take care of that for you. So that that is great for interoperability. That means like when you try and maybe you want to play with this in a new project or new game or whatever, you can mix and match them. It's not like you have to completely jump one way or the other. And now, so I'm gonna also, but for the sake of demonstration, I'm gonna have them both. You know what? How about not? I'll have the first call be the purely asynchronous one, and then I'll have the second one be based on the coroutine. The last thing we need to, sort of swap here is, well, now we need to swap out this wait operation, but actually that's okay. We can just say unit task that wait for seconds. And that's basically the exact same thing. We specify, it works literally the same way. You specify some duration and then it's done. Um, and now, well, how do we actually call it? Well, instead, I'll actually kind of get rid of this because this is just an example. So instead of saying, start coaching, blah, 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 all we have to do here is we literally can just call move up and down async and, start position, end position, coroutine, coroutine duration, just like that. And this will work. If we want to be even fancier, like maybe this is an async operation in of itself, we can continue to, I guess, actually, this is like, we'll have this be unit task. Oh yeah, and in general, like anytime you have like an asynchronous operation like this in C sharp, if you want something to be able to actually wait for you to finish, you have to be like of like some sort of task type. Like the return value has to be a task. If instead you have something like this where you just want to trigger something to happen, but you don't necessarily want somebody to be able to wait for you to do that thing, then you could do void, which basically is like you can stage some sort of asynchronous operation, but you're not going to be able like you can be treated as like a regular function because like other like basically people calling you will just call you and then move on, but you can continue to do things on the side. So now I can actually wait this. And we can even say maybe after we do this, we will say we're done. And now, oh, and this is particularly important too, because remember how I said Unity doesn't like it when you have like actually, Unity also won't like it if you have a non-void return type. I think it will also not let you put a context menu, but because that would invalidate this because it's returning type of unit task and not void. That will make Unity unhappy. But doing this sort of async void, where we're basically sort of erasing the notion of like something to await on from our caller, Unity doesn't actually does is a Unity treats it as a regular function, and so it still works, which is kind of nice. That is, I know I kind of like jumped through a lot of sort of like topics at once really quickly there, but lo and behold, yeah, we saw our start move operation. And when I hit play, uh, if I hit start move operation, it works just the same. That the first up is purely through asynchronous code. The down is through a coroutine. It's the same coroutine that you witnessed with my own eyes, like developed with you, and we did it through Unity's native methods. I didn't change anything. And now we even have the ability to await. And like we see at the end, it says done when it's done. But I'm not even done yet. The cooler thing is that if I come up here to window, you notice here that now I have this new panel here called Unit Task Tracker. And if I open this and I'll have it here, I'll say enable tracking, and I'll kind of put the inspector down here as well. What the really, really, really cool thing about this is that not only will it allow you to do all these crazy async operations, it'll allow you to track them too. And I probably have to, yeah, there you go. So now you have to enable auto reload and enable tracking, but you can see that it will actually show me all of my asynchronous operations happening at once, which I think, I don't know about you, but like that is really wickedly cool. So this, I like, let's say if I can like start the move operation, I can pause it. I think there's, I think if I enable stack trace, I can maybe get even more detailed metrics about what's going on. Yeah, there you go. So enable stack trace will have more of a performance hit, but it will allow me to get more insights into where this task is actually happening. So now if I pause it and I look through, you can see exactly where this call is happening. So if I click like this blue link here that says move up and down, this is the waiting for 1 second operation. I don't know about you, but I thought this was really cool. Like, especially if you're trying to debug some long, elongated like data fetch operation, whatever. Like this can help you keep track of that. And it's really cool. Now, as much as I love this, there are downsides. Number one, because so they're doing sort of some black magic to sort of not necessarily evade um their so you'll notice that we established beforehand that for something like for our coroutine to start we had to call start coroutine, but clearly we're not calling start coroutine out anywhere. Like if I look through you can trust me, it's not here. I believe how this works behind the scene is that they're literally they're injecting like a bit of code directly into the player loop, and they're basically sort of running in their own sort of like enclave there, and that's what at that point in the player loop That is where they're running all their asynchronous operations. Uh, and I um, there's more specifics on this online. I wouldn't take too much of what I'm saying out loud like as true fact, but you can read up more on the technical documentation. But that's sort of how they're able to cause like this like coroutine-esque behavior to happen, even though it's not directly being tied. Like for example, like when you call start coroutine, um, you have to be a mono behavior. You have to be a component. So like it's running off of some like mono behavior component like runner, like in the sense that like there's an instance of a component starting the coroutine. But nowhere in this did we specify a reference to ourselves. Like this is happening. We did not specify like functionally as far as this code is where it has zero idea that like it was us that called it, right? We could pass this on to anywhere else and it's be just the same. So there are caveats like that. Furthermore, I believe the one drawback or the one catch is that when you're editing your program or you're debugging whatever, the unit task doesn't know when to stop. You may hit like stop here, but I believe there's instances in which your task can keep running. Whereas with coroutines, Unity would have just like, sorry, bud, you gotta go. With unit tests, they may drag on longer. So you might have to explicitly um, like sort of stop them. But that's a good point. How do we stop them? We don't have a stop coroutine anymore. It's just like a fire and forget coroutine operation. This is where kind of like the other kind of little events tidbit of knowledge comes in where now we get into the question of how do we actually tell our thing to please stop, like we want to stop you instead of doing something like stop coroutine. Now as parameter, and typically what is behavior as parameter to our async functions, we now want to pass in what's called a cancellation token. And this is a C sharp built-in like struct, but this is basically a way of like you can think of it as like a token you give in, and this token is basically like a little. Can you imagine, like, for an analogy, at restaurants when you're like waiting for a table and they hand you like a little buzzer, then like when it's time for your like turn, you're waiting outside, the buzzer buzzes like, okay, come on and get your table. That's basically the analogy of what's going on here. This token is that buzzer, and basically, um, it's a way of like telling your asynchronous code, when the buzzer buzzes, stop it, like stop what you're doing, like break out. Um, that now in doing so, you'll notice that that means that you are responsible for stopping. So beforehand, Unity, with coroutines, it would do the sort of it would be nice to you. It would make it so that like if you were yield returning null and then you got stopped, well, Unity would take care of that. That would clean it for you. No, with the cancellation token, now you have to know when to stop. So, but how would you actually know when to stop? So in this example, um, we would say, while we look at that, look at wow, writer. Yeah, basically, while we still have stuff to run, and this, not right, not token dot is cancellation requested. So this is basically saying like while we still have time to run, we're still animating, but we haven't our token hasn't buzzed yet. That is to say, there's this like property here called is cancellation requested, which is literally as the name describes it, like have we been like requested to cancel or to stop. We If we are not canceled to stop or requested to cancel, we keep going. But you'll notice basically as soon as like we get notice from our token that like, hey, stop it, then this condition will no longer be true. We break out of the loop and then like we exit out. So this is a trade-off, I guess, because now you have to basically manage this yourself, or maybe find some clever design patterns where you don't have to worry about it. But let's go on through and sort of illustrate an example of how we can interrupt this token. So I'm going to pass a token like this, and like this. And you'll also notice too, oh, whoops, not like this. My bad. Wrong function. Uh, where did I, oh, here. Now I'll add in a parameter for a cancellation token. I'll put in a token here. I'll put in actually don't need it for here, but actually you'll see how I might be able to specify. So, um, You notice here that I have like a green line here. That's usually an indication of writer, like for the writer ID, that's basically it's saying, hey, by the way, you can do something that you're not doing. You should do it. So what is it suggesting? Well, for all the unit tests built-in methods like wait for seconds, wait for next frame, whatever, there's a way to actually specify, they have a parameter for specifying the cancellation token. So if you notice I just like specify, if I just accept the suggestion, now like you can pass in the token into the wait for the seconds. And so this unit task has already taken care, at least for its functions, it's taking care of the behavior of canceling. So this is basically a way of telling the unit task when you wait, listen for this token, and if it quote unquote buzzes, stop waiting. And but the last sort of piece of the puzzle is okay, we passed our token here, we can cancel out of that. We've passed a token to here, we can stop waiting. What about this coroutine? Because well, coroutines don't have a notion of cancellation tokens, generally speaking. They just run until they are killed. Well, guess what? Remember extension methods? They're back. So if I wrap this in parentheses, I'm pretty sure I can do. I can say or I guess, oh, not parentheses, but I think, yeah, here. There is an extension method for coroutines that will basically say with cancellation, and I can specify my token. So this is basically telling Unitask, run this somewhat magically, run this coroutine, but also like with this cancellation token. So in the event that like you're running and um, you get canceled, stop running the coroutine. So this is a fully, like after this, now we have a fully interruptible operation, right? We can interrupt the movement from start to end. We can interrupt the waiting, and we can interrupt the coroutine running. Again, this is the trade-off, right? This is more complexity on your end, but this perhaps gives you a bit more control of what happens if you do get canceled, right? Because beforehand, when we canceled a coroutine, that was it. Like lights out, buddy. Like you return null, you're not coming back. There's no cleanup necessary. At least I don't believe there's a. Well, maybe there's, but here, when you at least when you get the token, and when you cancel it, you yourself can perform any sort of cleanup logic you want. Maybe you want you go back to like the start position, or you, I don't know, but that gives you the power to do that. So the last bit of piece of the puzzle is now where do you actually get a token? Well, in C sharp, when you want to be able to make cancellation tokens and actually control, it's not enough to have a buzzer, right? You need to actually have a mechanism to buzz the buzzer. So how do you do that? Well, that is where the cancellation. I can't spell cancel. Cancellation token. Oh, can't spell either. Cancellation. Is it two L's? Source. Cancellation token source comes in, and we basically have our source be a new cancellation token source. So what this is, and actually, for the sake of cleanliness, we're just going to have it be all one line. Oh, by the way, additional C sharp pro tip: anytime you have, at least with the newer version of the C sharp, if you're sort of initializing a new class or instance like this, uh, and like the type is explicitly defined here, you actually don't need to specify it again. You can just say new. It's kind of convenient. But anyways, with this source now, this is basically has created a buzzer and then a buzzer that like allows you to basically trigger the cancellation. So now, we still need a token for this, but the way we get the token is we basically, oh, look at that, source.token. This is basically, this is the token that the source has generated for us, right? So now, let's make a cancel operation, or like cancel move. We will have it be a context menu thing so we can trigger it, so we can say cancel move. But now, how do we actually buzz the buzzer? We call dot source dot request. Actually, I think we call source dot cancel. And this is basically, at the restaurant, the waiter presses the button on their control panel, or whatever, the buzzer buzzes. This is how you basically update the token to say, hey, cancel, move on. So let's see this all in action. Clear this out, and where I have a syntax error. Where is that? Line 67. Oh, whoops. There we go. Now, if I hit play, I can come down here. I can hit start. Oh, just kidding. actually might be problematic. The one thing I think the one thing you do have to be mindful of is like once you like use a source, you buzz the buzzer, you can't reset it. Like you have to basically make a new. At least I'm pretty sure that's the case. I can kind of like I don't believe there's like a source dot reactivate or anything like that. Yeah. So like once you use the source, you have to basically make a new source to like start another operation. So basically we will only be able to start and stop our like thing one time before I have to relaunch it. We can address that again in the code, but so you can start move operation and then cancel and let's see. So it gets the oh yeah. So this is cancel as you can see it stops it like dead in its tracks, but I guess let's see where did it particularly stop? It does throw an error somewhere. Let's see, line 18. Um, oh, I guess it might be. Oh yeah, here it might be unhappy that like uh yeah. So this is sort of like the trade-off. Like if you don't like, I think it might throw an exception if you like cancel it and then uh you depend on it in some way. Let's say um. I don't know. I'll find out where, like, how exactly this error is coming up later. Yeah, yeah, I think that's right. Because, like, oh, it might be Unity itself telling me that it might have been canceled. Yeah, yeah. So, right. So we should be able to do, like, I guess this. I feel like I might be mistaken because I feel like there is a way to get so we don't have to do that, but that's like the way cancellation token. Where is it? Like, what was the particular? I guess it's gone now. Or whatever. But there's a way we can catch it as well. But we can also notice that like the other thing we can do is when like because we now have, like we move like the cancellation of our operation onto ourselves, the caller, we can also like do maybe do something in particular when it gets canceled. So now here, let's say we interrupt this, I can actually check at the end like if is cancellation request, we can like maybe print out the warning message saying like we were canceled. Yeah. In my next frame. Oh, okay. I think I forgot to put the token like here, sneaky. You can also specify the cancellation token next frame. I think that's what I was missing. Because I think if you forget to specify the token anywhere and like some async operation gets interrupted, it wasn't expecting to be interrupted or something. Maybe that's what gets mad. We'll see if I'm right or not. Hit play. Now if I hit start, blah, 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 we cancel it. Okay, whatever. It like it still gives the error. I think probably I am probably forgetting or omitting something somewhere. Um, oh well, like I'm sure, like there's examples online in the repo that like always show you like maybe more proper ways to do this, but basically there is a way to like get this to be pretty nice, where you can specify the tokens and like cancel it. And this is basically sort of the way you would go about doing it. Like you provide in this like token check and like operations where you need to know whether or not to cancel, and you do so like that. Yes, correct. So yeah, so like you could still, like you said, you could do a similar like with a coroutine, nothing's stopping you of doing either like using like literally like the same sort of struct, like nothing stops you from like doing the same sort of check in a coroutine, or like a very like a simple approach where it's like you just like you said, just have a Boolean flag. You could do the exact same thing. I guess here you're kind of forced to do in this design pattern. Um, I I personally am motivated enough, like after this workshop, to figure out why this isn't working. I'll post why maybe it is or it is not working. But obviously, but I hope at least this introduces you to like maybe a different way of doing like asynchronous operations in C sharp. Is it worth it for everybody? Probably not. Actually, no, definitely not, right? Like if you're just doing like a simple game, you don't necessarily need all this fancy asynchronous operations. But I personally felt the kind of the desire to highlight it because, well, maybe if you are doing a bit more of a data-driven game or application where you do legitimately do a lot of like asynchronous calls, and you're mixing async code and whatnot back and forth, then it might become useful for you. Oh, and that reminds me, the other cool thing you can do with async is that, as you might know, with Unity, anytime you want to like change something about Unity, you have to like do all of your code that affects Unity within the main thread. Like Unity hates it when like let's say you might have like let's say you want to have like a button or whatever that like reads like a player's save data, and then once that operation finishes you like display a message to the user saying like your save is loaded, right? If you go on the main thread, you create that other thread to start loading that data, and then that data tries to like show like activate a game object or whatever while not on the main thread, you need to be like no. You have to like basically everything that can happen in Unity has to happen in the main thread. But that makes sort of like our synchronization code a bit difficult because you want to maybe like uh, do something in Unity, go off in the background, do some like work, download files, read or write to disk, whatever, and then you want to basically jump back. The other useful thing about Unitask is that if you happen to be in one of those data-driven operations, you can also do this thing here, or actually not here. Same thing here, where you can say await unitask dot whoopsies. I think background. Can I say thread? Yeah. So you can say switch to thread pool. I believe there may or may not be extra code you need to like set this up, but basically this allows you to do some like do something truly on a different thread, right? So something that will not affect Unity's player loop. So even if I had like an infinite loop here, this wouldn't technically matter because this is not the Unity main thread. This is the player loop. The player loop will go on. And then once you do finish your work here and you need to affect something in Unity, you go back and you basically say switch to main thread. And so in this way, you can combine that work and make sure that like you're being proper and like you're waiting until like it's a good point to come back into Unity's loop and you can continue affecting Unity stuff. I particularly had to do an operation like this for like my weather visualization project. So I can pull up really quick. Let's see. Like here, like um you can imagine like, for this particular app, right? Um, you have these big weather climate data sets, but obviously you don't want to read them in Unity's main thread because these are huge gigabyte file size data sets. So, you initiate the loading in Unity, you maybe display a pop-up message to you just saying like, I'm loading your data. You jump to the background thread, you actually read that data asynchronously, but you don't do it in Unity's main thread so that, they continue having like a smooth VR experience. Like it keeps running as per usual. And then once you do have that data, you jump back to Unity and you load into a texture or whatever. So yeah, that is basically a brief overview of Unitask. Is it for everybody? Like I said, no, probably not. But I particularly found it useful, and I hope that you guys might find it enjoyable as well. If maybe um, that it might be something to use. Let's see. So we have about 15 minutes left, so I'll just kind of cover some maybe minor topics. Uh, let's say you want to maybe spice up your like your text game. You want to show like whether you're showing a menu in game or in the console, you want to like let's say make your messages stand out. So let me show you an example. Let me make a new script called console utility or whatever. And let's say I have like a public method. I'll also zoom in so you can see it. And I'll say, no, my message, right? We'll use one of our fancy schmancy new tricks to add this to our context menu. and we'll come back into here, and we'll like make a new game object. We'll also like put away this unit test tracker because we're not going to use that anymore. Put away the test runner 2, and we will remove this. We will now add our console utility. All right, so pretty straightforward. We call our show message function. It puts a message in the console saying, "Here's my message." Great. I mean, it works, but couldn't we make it cooler? Or rather, to sort of like define it a bit more objectively, like, can we alter the visual appearance of this text for our benefit? And the answer is yes. For example, classic question: how do you change the color? Like, maybe you want to like particularly like change the color of the message if it's like maybe it's a super critical message that you show in purple or something like that, or whatever. Wouldn't it be nice if you could do that? And you know, uh, the answer is you can do that actually. But how do you do it? Well, Unity actually supports in most of the operations where it goes to display text, it supports something called rich text. So I'm actually going to Google that really quick. Unity rich text. And there used to be this really great guide that doesn't exist anymore that I think I can find here. Yes. So I use this all the time. This is basically part of the TextMesh Pro documentation, but this is all the different ways in which you can stylize text, either in like a UI label or, and I think a subset of these are supported within the console. So how does this work? Let's say we want to change the color, right? We're going to go down to this color thing. So basically you see like what we need to do is we're going to add these little tags into the text that are going to basically instruct Unity, hey, when you go to render or visualize this text, you need to, well, spice it up, change it up. So in this case, change it to red. So let's see what we can do. We're going to see now what happens if I say maybe change this color now to, I don't know, blue, because blue is not a typical console message. I'm also going to have to use like an escape character because it's going to not like the fact that I have like these backticks like this, and let it recompile and hit play. Now, if I hit this, so message, oh, I probably have to add the closing tag. Let me try that. If this doesn't work again, I suspect that like I might have to specify the hex code of the color. So we'll see that. Oh, no, it does work. Okay, so yeah, all we have to do is specify in tag. And bada bing, bada boom. Look at that. I guess it's actually really hard to see here. My bad. But we have a blue message and it goes all the way through. Not only is it blue here, it's blue in this little tooltip thing down here and in like the actual stack trace itself. So this is particularly useful, I guess, if you want to be able to maybe like separate visually like your log messages based on their concern, right? Maybe you might show all debug or log messages pertaining to an enemy in like a orange color, or maybe everything related to your game managers in like a cyan color, whatever. You have the ability to do that, but it's not just color. You can also, I think you can also bolden text. So if I say this is a bold message, so we use B as shorthand for that. And I think you can even also do like italics too. So we can say, and this is italics. Oh, wow. So fancy. And I think it's like, for you web developers out there, similar to like these HTML opening and closing tags, and you can use it to show text like in a very intuitive way. It should be pretty similar to what you're used to. And if I play this now, and if I show my message, yep, there you go. See that? Well, actually, you might not see that. Oh, well, like you'll have to take my word if it's a little hard to see. But yeah, we got bold text there, italic text. Pretty nice. So you can format, definitely it'll help you like maybe format your messages. But the best part is this is not just for console messages. We can actually use this in game. So take a look at this. I make a canvas, like this, I'll do UI canvas. I'll import. Oh, you will need Textures Pro for this, I guess. And I will make this. Actually, we can leave this in screen space because we're not going to be doing VR in this case. I come to 2D mode. I come view the canvas. Let us position the text to be in the, I don't know, the lower left center. So we'll just do pivot down here, 0, 0. Also, we could even have our own workshop on UI in particular, but what I'm doing here is that I'm setting sort of the anchor point to the bottom left corner by setting both these O, or like the pivot down here. This is basically saying from where this little label will be manipulated from, like where's the pivot, and having it both be 0, 0, I think puts in the lower left, although I could be wrong. We'll see actually where it ends up putting it. No, it is lower left. Okay, cool. Now we'll just give it some arbitrary. Actually, let's give it make it stand it maybe a bit further up. Give it some width. Give it some height. And the best part about this is that you can use these rich text things here, and you don't even. I'm pretty sure you don't even actually have to go to play mode or anything. They'll just sort of apply instantly. And let's see. Hopefully we'll see that in action. So let's try doing the bold and text example. So if I say new bold, close the bold, text. You see that? No play mode required or anything. It's like applying those effects immediately, and we can actually wrap them. We can even do color here. So I can say color equals red, and now the color is red. And the nice thing here is that, like, yes, you already had the ability to change the like the text color by modifying the vertex color here, but because this is, all specified through these attributes, we can change it. We can have multicolor, or we can make multiple colors. So I can make this yellow, and now we go red to yellow. So this is a particularly nifty way, right, of like stylizing your text. I definitely use it a lot for. Actually, I'll show you how I use it. Usually, if I'm lazy and I don't want to make, maybe I want to kind of show like a panel of some information. I want like a header that's larger, and then my like fine paragraph detail. I will go to this list here, and I'll go down to the size attribute, and this will let you also dynamically adjust the font size. So let's say I think you can specify it in either like uh, concrete font point sizes, or like you specify the size literally, or you can do it in terms of percentages. So you like 100% will be, excuse me, whatever you specify in the editor here, and then you can specify a percentage off of that. So let's say I want a blue header and then some text content here. Now I can also come here and say size equals 200%, but that will make everything bigger. But in order for it to just apply to the header, I can just add this closing tag here, which is done by like this, tag this slash here, and then I'll just do size. So say and the size effect here, and then there you go. We have a larger header, but our regular text content size. And I use this a bunch, like I said, for displaying information. And the also nice thing here too is that like it's also generally, I think, easier to program around, because instead of maybe like, you want to like dynamically adjust some of these properties, you don't have to set like a gazillion parameters here. It could literally all be encompassed in like the string. So this is very good in terms of portability, because you can literally like encode these strings, all this sort of formatting, as just text, and then you can just feed it into Unity. It just works. Pretty nice. And I use this to the fullest extent. I'll show you, to like, let's say I'll toot my own horn for a second. Here, I'll show you a cool way I kind of do this. So one of the ways I use this library, or the ability to sort of colorize text, is through like a little console utility I made. So, this is also free. So if you ever want to like maybe check it out, or like, I don't know, contribute to it on the two. This actually utilizes rich text behind the scenes to help stylize text. So I'm going to grab the console, and then I think I also need the core. I'll install these packages real quickly. Oh, this will also be cool because I can actually modify the font size here. So basically, the purpose of these libraries, uh, why I made them is that like in Unity, you have the console where you can output information, but there's no good way to input information, right? Like maybe, you can output when you do things, but maybe you want a command that like quickly, you know, changes like an enemy's health or whatever. Well, this is what I tried to address with this console. So now if I come up here, there's the tactile console. And if I can actually like, let's say kind of put it through here. And now I can actually treat this like a command console. So what I'm doing is that I'm actually you know building up this console command or this output by using those rich text tags that I just showed. So I can even here actually the cool thing is I can change the font size so you can actually see it better. Now I can double click it, but I can actually literally I can even make it even larger. Whoops. Um, the cool thing is that literally you can see here that I have a command called rich text, which turns it on and off. So I can literally show you what happens if like you don't have rich text. All right, it's text. I think it's a rich text. And then now if I run it, all that color information is gone. And this is cool because I think in Unity, there, at least in like when building some of like the editor UI, you can actually tell it whether or not to actually obey rich text. That is to say, like do you actually like pay attention to like do you do anything with the information you're given to you? Just ignore it and just display all regularly. And this would be an example of just ignoring it altogether. But yeah, I figured that is like a pretty cool way to demonstrate how you can use rich text, especially when you're like, trying to make debug utilities or like show UI within the game or whatnot. And yeah, so pretty cool. But that brings us to 5:57. We're 3 minutes till 6. Obviously, there are tons and tons of more techniques we could go through. I would love the app more and more and more and more and more, but we have limited time of the day after all. But if any of you are particularly interested in like any more of these topics or um, like maybe diving further into one of these particular topics and looking for the workshop, by all means, reach out. We can, schedule that, or you can come talk to me afterwards. But yeah, other than that, I hope today you learned some nifty things about when it comes to extension methods, coroutines, how we can even use async await with Unity, and then last but not least, how we can stylize our UIs and our console messages with rich text. So have a good weekend. We will not be meeting next week because I also don't want to be here next week. So I definitely, I imagine most people are going to get on their merry way with their Thanksgiving breaks. So we will skip next week's meeting, but we'll see you the week afterwards. So thank you all.